I am J.R. Richardson with Integrated Solutions. We're a boutique premier service provider for businesses, voice and data services, MPLS networks. So most of my customer base is on net to me because I provide the service 100% out to the customer. Okay, so voice networks connected to the internet, the public internet I should say, are constant targets for scanners, people wanting to make free phone calls in your system, through your system. So it's, I used to take it kind of personally. If you've ever been hacked, it feels kind of like your first night in prison. You feel extremely violated, but it's not personal. It's just machines out there, botnets, they're gonna scan you, they're gonna try to make phone calls to your system. What we're gonna talk about today is using fail to ban, which is a log scanner, and we're gonna read those logs and we're gonna automatically, when a specific log message comes in that you had a hack attempt, we're gonna automatically generate access list on your gateways to block those attackers. So here's a common VoIP attack. Hopefully you can see this. This was a honeypot PBX I put on the network, public IP address. Went online June 21st at 5:14 in the afternoon. What you're seeing here is registration attempts. Started 3 hours and 13 minutes after this machine went online. And what you see here is they're scanning extension 101 and all the way down through 9999. So a scan from extension 100 through 9999 completed in 120 seconds, 2 minutes, okay? That's a lot of traffic hitting your network, hitting your PBX, okay? So I had some just generic extensions on there that gave a response that, hey, extension 605 is here. Once the initial scan happens to identify what extensions are on the system, then the scan starts to do a password attack on valid extensions. So in the initial message you see no matching peer found, but when it hits one, you'll see a different message that says wrong password. The password, which I had set at 1234, was cracked in 35 seconds. And then, so this machine was successfully hacked in 3 hours, 15 minutes, and 35 seconds from going live, okay? That's pretty quick. But well, one thing I wanted you to notice is the actual IP address that the phone calls were attempted from is not the same as the scan. So you have scanners from different parts of the internet are gonna, they're gonna gain access to your system or get the authentication access into your system. They're gonna ship that off to someplace else that's actually gonna make the phone calls. And of course, being a honeypot, I just played back TT monkeys, so when they routed phone calls to, you just heard a bunch of screaming monkeys. I'm sure they loved it. So this is a registration attack. So as complex as you can make your usernames in your SIP.conf, they usually, you know, they're pretty slick. They do all kinds of, you know, 2222 and 2 kids. Look, here's one that says 57 Chevy. So even though you're using common names or stuff, they have all these. This was just a blurb of about 100,000 registration attempts for registration attack. Okay, so who in here believes or is the mindset that the PBX should also be your security mechanism? Show of hands, nobody believes that? We got a couple, okay. So a small system, it's, you can run the PBX application and also a security application on there. Now, who's of the mindset that security should be handled off the PBX? I agree with that. I think you know, security should be done on a security box that's specially built to handle the load for security. Fail to ban is going to scan logs, so it's just a log scanner. Who does not know or not familiar with fail to ban? Okay, so this is a great project. It's been around a long time. It's not VoIP specific. It's pretty agnostic. You can also use it to block www attacks and all kind of SSH attacks. So it's not specifically used for VoIP. The project's been around a long time, it's very mature, works great. You have to use strong passwords. 1, 2, 3, 4 does not cut it. But that was just an example. Okay, so in asterisk specific, so in the general section, you always want to put a context. This is in the general section, that's where anybody can access your system, right? So a bogus context is in, if they do successfully gain access to your system through the general context, you don't want them routable to your internal dial plan or your external or outbound dial plan. You just you stick them in just a place that goes nowhere. Allow guest is no. That means that you have to have a valid peer in the SIP.conf to gain access through the SIP channel. And this also applies to the other SIP channels as well. I mean, the other asterisk channels being H323, the skinny channel, IEX, the same thing applies. In the actual user context, so in that extension 605 or extension 1001, you want to use the deny and the permit statements for, you know, it's just basically a little access list that you're doing there. And what this does is when you get an attack, you're going to get a very specific message in the log that says ACL denied or ACL error. And we want to use those messages, we want to match on those messages. So it's important to do that. Another thing is when you're permitting your networks, these are my networks, okay? I'm permitting specifically only my networks. I'm not permitting the entire internet to access the box of the machine. And of course, VoIPinfo.org has some great things about security. I encourage you to take a look. So a Cisco access list. It's a mechanism common in Cisco routers, switches. Access lists have been around a long time. So it's security, using security mechanisms to block access to the network that you're trying to protect. So real basically on one of my VoIP access lists, I specifically permit in the front. So also an access list is read from the top down. All right, so it reads, and as soon as it gets a match, it sends the packet on through. So I specifically permit networks that I never ever want to be blocked. So who would be 4.55? Who knows who that network is? Level 3. That's level 3, okay. Upstream, this is just an example. Upstream SIP provider, right? You don't want an attack happening and then automatically block that network. And you want to be very, very specific in the networks that you do allow. The subnets, you don't want to lock it down. And then, of course, I have the scripts that I use block between 101 and 300. That's a rotating number. You'll see that in the scripts where when I apply a access list, when I get to count 300, the script will revert that number back to 100, and I'll start at the bottom again and work my way up. And then after that, you can specifically, what I do in my access list, I like to see what countries I'm getting a lot of attempts from. So I'll do the Class A's and block those. And then, of course, at the bottom, you have your implicit deny all. So here's general architecture. So you have hosted PBX systems as an ISP. This is a typical ISP model. You have your internet, you have your gateways to your internet, your local switching network, your users, your valid users out there on the internet, and you of course have hackers. Well, what I'm implementing here is a central logging server. So all this guy does is collect all the logs from the PBXs. He's running Apache CGI for some interaction in the emails that I get, and Fail to Ban, of course, is running on it, and Rsyslog is the syslog daemon I use to capture all the log files. So just the hacker flow, hacker attempts access to hosted PBX through attacks, different types of attacks. The PBX is configured specifically to send log messages to the central repository, the central syslog server. When a trigger occurs, Fail to Ban, of course, is running on that box. It's scanning the logs every second, and it's going to call the scripts. When it gets a trigger, it's going to call the scripts that are going to log into the Cisco devices and actually implement the access list. So just running through visually, pictorially, we're going to look at how that happens. Network's up and running. A hacker, he decides to attack this PBX. The logs are shipped off to the central repository server, and they in turn throw up the access list at the gate, and the hacker is thwarted. He must go someplace else. Okay, so now we're going to get into kind of the meat of it. There's a lot of information here, but just as a side note, I put the presentation up. It'll be on the website. I also wrote a Word document that has all the complete scripts, so you can get the Word document off the website and cut and paste, and these scripts will pretty much work out of the box. The Linux-based server, right? So all it's doing is sitting there collecting log messages and fail to bans running. It's a very low usage, low processor, low resource. It's just going to sit there and run. There's not a lot going on there, so you don't need Dell R710 or a compact one of the big servers. This is, could be on an old Pentium white box special or something like that that you repurpose. MySQL data, well, of course, fail to ban is the log scanner. There's the website, failtoban.org, been around a long time, great community. Open source project, of course. MySQL, I use a MySQL database. You don't need it, it's not necessary, but I also do other logging functions, and I put all my logs into a database and use the Adiscon log analyzer. It gives you the web front end, so you can go in there and do detailed searches in the logs and just find all the good stuff. And of course, I use on the server, I'm running Apache with CGI because I'm interacting with the server. When I get the notification emails, I can do stuff. PHP module, if you need PHP, and the PHP module for MySQL if you're going to use the log analyzer. Okay, so here's the Rsyslog server. Rsyslog out of the box is Debian distribution. It's the main syslog engine for Debian. If you don't have it on your system, it's probably just a package download, or you can install it directly. You can go to rsyslog.org, I think. And so what you want to do, out of the box, it does not listen for log messages coming to it. It just acts as the localhost logging engine. So you have to mod load IMUDP, which turns on the service to receive log messages. And of course, you tell it to, you want to use port 514, or you can change the port. 514 is the default syslog port. So Asterisk by nature is a pretty chatty, you get a lot of logs, okay? So you don't want to get all the logs. You want fail to ban to be scanning the smallest log possible. So if you have phones on the internet and it's a bad connection, what happens to the phones? They drop off registration, they come back. So you get a lot of these kind of noise logs where they're just not needed. So you can, Rsyslog has a mechanism to discard these messages so they don't fill up your logs. So fail to ban doesn't have to read through them and try to match. So you can put these discards in there to keep your logs as small as possible. So by default, it's in at var log syslog. The messages will go. You can actually specify local 0, which is the asterisk, which we're specified in asterisk. We're going to use the local 0 tag for the syslogs, and you could actually send those logs to be scanned in another log file, wherever you like. So Rsyslog also has an embedded SNMTP engine emailing, so we're going to load that module. It's called OnMail, and you set up the domain and where you're going to send the logs to, or the emails you're going to send them to your sysadmin, whatever. And then you're also going to specify if the message contains wrong password, then you're going to call OnMail and send the message. If it contains forbidden, if it contains acl permit deny, if there's a syntax error. So you can specify what messages you receive as the sysadmin. And of course, once you make the configuration, it's a typical Linux daemon, you have to restart it. So here's the PBX setup. This is a typical message you're going to see in your logs. So SIP channel, registration from blah, 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 failed for blah, blah, acl permit deny error, okay? So we want to get these messages from asterisk to the central syslog engine, right? So asterisk doesn't natively have a mechanism to send the logs, its logs, off the box. But it does have a mechanism to go ahead and do syslog local. So asterisk will send its message log to the local syslog engine on the PBX. And in the syslog configuration of the local PBX, it natively has a mechanism to transmit those logs off-site. So this would be the IP address of the Rsyslog server. So once again, asterisk sends its logs to the local syslog server, and then the syslog engine on the box just natively transfers those logs out to your central repository. All right, so we'll talk a little bit about fail to ban. It's got several config files. We'll step through them. The first, of course, when you do the fail to ban install, it's mostly a package for damn near every distribution. You can just use your package manager to install it, or you can install the latest source code from the website. So its configuration files are in etc fail to ban jails.conf. So this is an important section for us. So in jails.conf, it defines all your jails. So you could have multiple jails. I just have one jail here as an example. So, but in the default section, you have a switch called ignore IP. This is pretty important. Notice I have the private IP addresses. If you're getting registrations from your local LAN and a phone went out and it had a bad password or something, it's a legitimate, it's a false positive, right? So it'll generate a hacker attempt, and fail to ban is going to act upon that unless you ignore those IPs. And of course, as a service provider, I ignore my IPs from my customers because I control all that network anyway. So I make sure that one of my phones doesn't go out with a bad password. If it does, it's okay. I'll get the error message and I'll go fix the problem. But because it looked like a hacker attempt, fail to ban is not going to act upon it, and it's not going to shut down that network for all the other 200 phones on that local network. So this is a pretty important guy right here. Okay, so asterisk is it's just a name, right? It could say you could be SSH or anything. It's just an arbitrary name. We're going to enable it. The filter is going to be called asterisk, which is another file that we're going to look at. The action, when we get a hit on the filter, we're going to do something. So this guy is going to send us, fail to ban actually sends an email and lets me know when fail to ban acts and says, hey, I just blocked somebody. And we'll look at those emails. Max try, I think it defaults to 3 or 6 or something like that. You have one attempt to access my network, and if that generates a log, I'm going to block you in one attempt. I'm not going to wait 3 times or 10 times just to see if you're really serious about hacking my network. You got one attempt, and we're going to block you. And then you have some timeout mechanisms for about 5 minutes to replenish. Okay, so here's the filter. This is what we're going to filter on. This is Linux-based regular expression type syntax. It's a little arcane if you're not very familiar with it, but basically we're going to match on the message. This is the whole message, okay? So you have to have your spaces in the right place, your colons in the right place. What are you're matching on? Device does not match ACL error. Then you have a couple of switches in there. Now, the good thing about this is it's already on the security website, not only here, but there's more. There's more stuff that you want to match on. This is just an example. So you don't have to write this yourself. A lot of people have already implemented this, and it's out there on the web. You can cut and paste and do these matches. Okay, so when a log entry is matched in fail to ban, we're going to call this file in the action.d directory. It's called ACL, which we called in our in the other configuration file. We're going to act on it. What are we going to do? The action ban to ban it. Now you can also have an action to unban, so you can dynamically add and take out ACLs as needed. So this guy is going to call, all we're doing here is we're going to specify the ACL execute.perl, it's a Perl script, and we're going to also add the variable IP. So the IP is getting from the host. So in the registration failed attempt, you have this variable host that is going to go into the IP parameter when we call the script. All right, stepping right through. Now we're going to look at the actual Perl script that does the work. It's going to apply the ACL. So it's in the action.d directory. It's an executable script. It's written in Perl. You have your typical Perl handles up here. What we're also going to include in our Perl libraries is telnet Cisco. So we're going to be telnetting directly into Cisco routers with this script. And we're also going to include SMTP, because, hey, I like emails. I like getting a lot of emails. So this script is going to send me an email as well. So I've got some triple validation when I get a hacker attempt. I've got Rsyslog sending me an email. I've got fail to ban sending me an email. And I've got these scripts sending me emails as well. So it just validates what's going on. You set some parameters. I'm not going to get really detailed here. You know, Perl is a great language. It's simple. There's a ton of documentation about how to set these up, set up variables. If you're not familiar with Perl, I suggest you read some of the Perl websites, beginning websites, and you can get up to speed really, really quick. If I can do it, most people can. So a couple of notable things here in the script, and this is the complete script, by the way. Open count, I do a count file. This is that mechanism where I counted my ACL number, my ACL number in the Cisco router. It's going to start at 100 to 300. So when the script count or the ACL count gets greater than 300, I just put it back to 100. Very simple mechanism here. Then we're going to actually set up the telnet session, username, password. You set up the commands that you're going to be running on the access list, IP access list, extended host, no ACL, because when this script is running, when you try to, say you want to implement ACL 122, the count is at 122. If you try to log into the Cisco router access list and implement or put 122 and 122 is already there, you're going to get an error. So the only thing we do here is we know that no access list 122, take it out, make sure it's out before I actually put it in on that same priority. The session information, also notable here is session 1. So at any given time, real simply, you can take this script and add a second session to another device, a third session to a different device. So you could be running access lists, multiple access lists. You can specify different names, access list numbers. So, you know, here's session 1. You could also have session 2, session 3, session 4, all within the same script. And then once I issue the commands, then the ACL count, I do the ++ in Perl. It just increments it by 1, and then I write that back to my ACL count file. So there's another file on the system that actually all it does is hold the number of the ACL rotation. So we're going to open the activity file. I do an activity. I like a lot of validation. I like my scripts to tell me what's going on. So I have an activity file on the Rsyslog server that has every event that the script actually accomplishes. And then also, if I'm running the script at the command line, remember this is all automated, so I'm not doing anything at the command line most of the time. But if I want to, if you're sitting there working the script, developing it for your environment, you put you print back to standard out so you can actually see what's going on in the script. Okay, all right, so now we're going to get into the email configuration. This is just typical Perl email SMTP setup. So you define who you're sending it to. I'm sending the emails to me. You specify what the message is going to be. You specify where to actually connect to your smart host or whatever you're sending it to, and you actually execute the email and send it off. So this is an actual email example. This is real world what I get. So I get an email, the subject line is, hey, we just applied 242, deny IP, we denied this range or this IP address and it's been applied. The message body is pretty much the same. It has a timestamp on it as well. Just for validation, it tells me the new ACL has been applied, telnet session's closed, and ACL count incremented. If this was applied in error, click this link. This is the CGI. I have another script on the server. This is why I run the web server with CGI. So I can actually click this link and automatically the script the delete script will just log back into the Cisco routers and pull that ACL out. So you're asking, well, why would you want to pull out an ACL that just got applied? So in the real world scenario, you have a user phone, single user office or something, the home office, they're out there and they're on Time Warner cable modem, and they lost power, the cable modem came up, and now they have a different IP address. Okay, remember in SIP.conf for that specific user, I have ACLs applied. So I specifically tell the system that that IP address is allowed to register with my system. If his home IP address changes, then it's going to automatically, the setup here is going to automatically block them. So at that point, I would get the emails and I would log into the Asterisk server, into that SIP user, and say, okay, this IP address, their new IP address, is now authorized. And then I just go back to the email, click this link, and it automatically pulls the ACLs out of the router without having to log in. It's just a little extra step, a little extra script to help automate things. And the delete script is pretty much the same as the apply script, but we're just sending the no ACL and writing the activity to the file, printing back the standard out if needed, and sending another email. So basically, one attempt, I get 4 emails, or 3 emails. If I delete it, I also get a 4th email. So the ACL number is just a number in a file, specific range it just carries. Not all 3 of these would not be in a file. It's just an example. So I would only have one of these numbers in the file at any given time. ACL changes. This is just a file that stores all my events. So at any given time, if I wanted to look at what's been going on the last month, maybe I took vacation, or I get the email, so I see what's happening in real time. But if I want a historical record, delete the emails, and I can always go back to this file and see what's going on. So here's a real world example of a Cisco ACL. It's within my block range. I just took a snapshot of what's going on. I blocked the whole Class Cs, just personal preference. So what we see here is a good example. This guy and this guy. This was an intelligent scanner. So not just a regular SIP vicious or something like that. What it does is, if it does not get, so it'll be sitting there scanning my network, right? And as soon as it does not receive a reply, it knows it's been been blocked or something, it's going to stop scanning. It's not going to waste any more resources. It's going to move on to another IP and start scanning there. This guy right here was probably a less sophisticated scanner. So even though he's blocked, he's still scanning my network just because my IP address was loaded in the scan utility. And it's trying to scan 100,000 registration attempts. He's blocked, but he's still going to scan even though he's not getting any replies. So just a review, you have users, valid users registered into your system. A hacker attempt comes in. All the hosted PBX services throw their logs up to a central repository where fail to ban is running, constantly scanning logs every second. And within a second or two, within max I've ever had is about 2 seconds before the ACL is actually applied and stops the hacker at the gate. I'll keep that slide up. That's about it. I'll take any questions now. Yes. Off-net users are, from time to time it happens, but very seldom. Yeah, I could do 200, 300. I could do as many as one as personal preference. Really, I only cycle through. I get so few attempts, actual attempts that get blocked, that from 100 to 300 range, I don't cycle through that for about 6 or 8 months. I used to get a lot more attempts, but since I implemented this, and the real key is on the access list, I only allow people who are authorized to get to my network. So it really cuts down. That's the majority of what cuts down. But even if somebody's on say I allowed a network for Time Warner cable, I have a specific user in that net block, there may be another compromised machine in that same Class C, and I get attacked. And so I'll block that, and that happens not too often, but it does. Next question. No, I block everybody implicitly. I don't allow just unfettered access to my systems. You have to be one of my users, and I have to know where you're coming from before I allow you IP access into my network.
Well, what if somebody does want to allow people from anywhere in the U.S.?
Then you're going to get a lot of hits. Yeah. It's just instead of running through 100 to 200 every 8 months, you're going to run through that every 6 days. You'll just constantly be blocking people if you have open access, which, I mean, it'll work. It'll still work as implemented in this configuration. You're just going to get a lot of attempts and a lot of blocking going on.
Does your fail-to-ban remove, like I know, like when I set a fail-to-ban with IP tables, it'll remove the block after the ban time?
Yeah, I don't remove the blocks unless they're, yeah, I just let them cycle through. They override each other, so, Yeah, if they keep their cable modem powered on and there's no issues, they're pretty much the ISPs nowadays. They like to bind the IP address to the MAC address of the device, and if it's a short power hit, it'll usually come back with the same IP address. If they're having a network issue where a whole Class C goes offline or a whole neighborhood goes offline, like a major power outage in the neighborhood, all the devices come up, and then it's anybody's first come first serve on IPs. Those IP addresses change. It's not really a big issue because it'll only happen. I don't have a whole lot of remote users, so it does happen, and it's just a maintenance event for me or for them to call in and say, hey, my phone's not registered. But what I see more often than not is when a user's IP address changes, a remote user, I'll get an email from fail-to-ban that they just got blocked. So I'll jump into the system and click the delete button, go into sip.conf and make sure they're allowed on that new IP address. And we usually do this in the morning time, so before the user gets up and has their coffee and starts to work, we've already cleared the error and the phone's already registered. I don't get a whole lot of calls that I don't know about that say, hey, my phone's not registered, can you unblock my IP? And it's also, we have very good relationship with our customers, so the customers, the off-net customers, they know what's going on here. I tell them, I got to specifically allow you. So if I have users that call in and say, hey, I'm taking my phone to someplace else, this is the IP address, can you go ahead and allow it? And they'll call me ahead of time when they know they're going to be on a different IP that's specifically allowed.
JR, I think it's worth mentioning, because in the sense of those questions there, you are kind of an obsessional blocker. You block everything, there's no expire. But fail-to-ban actually explicitly has a really good expiration thing, and you can set that to whatever you want. So my suggestion to people would be, and I'm asking for your condescension on this as well, but I think the answer to that is if you want to open your network a little bit, the first question about blocking countries, if you know you don't have users in China, you go ahead and block China. If you've got people on like mobile phones, you're never going to know their IPs ever. You don't even know what network they're on half the time. So in cases like that, you open it up a little bit, you play around with your expiration time, which by default is 10 minutes, I think.
Yes.
In my case, I'm totally opposite of his scenario. So what I do is I get an email every day saying what fail-to-ban is doing. And what I see every once in a while, maybe once a week, is somebody's trying to get in, and fail-to-ban takes about 2 seconds to cut them off. And then that's the end of it, because nobody's going to wait once, oh, let's see, it's 59, okay, I can try to hack again. So they're blocked for like an hour or whatever time you want. So in the case of your mobile user, if you're asleep, JR, and somebody's calling you, you know, they're going to have to wait until you wake up, unless you've got...
Usually, yeah.
So your comment on that, you agree, though, that you can open it up but not be totally open to attack still?
Sure, it's ultimately configurable for your operating environment. This is not going to work for everybody. I'm in a very specific business, very specific customer base. This works extremely well for me. But the tools are there. They're just tools. They're the scripts. You can modify them however you like. Fail to ban, you can configure it with different filters and different ban times on off to execute different things. It's just a toolbox. It's just tools in the toolbox to, you know, make it work how you need it to make it work.
You could even have it send mean notes to the email of the administrator of the network that's trying to attack you, if you wanted.
Sure, absolutely.
So why do you block /24s instead of doing a DNS lookup on the owner of the IP in his block and just block?
Sure. So fail to ban in the fail to ban actually does a who is on the IP. So in the fail to ban email,
not just who is. You can actually get those records through DNS, and it's a lot faster and a lot easier to parse.
Well, sure. It's configurable. It's configurable what information comes in the emails that fail to ban supplies. So back in the day, a few years ago, I used to be pretty adamant. I used to get pretty upset with people trying to hack my network. So I was I was always trying to contact the ISP that they were on, and telling those guys, hey, you're hacking my network. Stop that user. Block that IP address. And they were like, yeah, sure, we'll get to it. So at some point, you have to realize that people just don't care. I mean, look at Amazon. You can spin up an Amazon server for pennies and start hacking the world, and Amazon just doesn't care. So it's not incumbent upon the ISP where the compromised PC is. Technically, it is their responsibility as an internet service provider. It's incumbent upon them to prevent abuse coming out from their network. But in the real world, they really don't care. They got better things to do. So I take it personally to take care of it on my end.
I think it's fair to say that anyone in this room, if we got something saying, hey, your network's somebody's screwing with us via your network, we'd look into it. But that in general, what JR just said, the world really doesn't give a crap.
Yeah.
Actually, right on that point, I was wondering if there's been any kind of work on something like a community blacklist or something like that
Yeah.
would be more of a central repository, because a lot of these guys, everybody's logs pretty much looks the same.
Sure.
If you analyze them over a month's period, right, you'd be able to see the patterns and things like that. Has anyone ever started talking about that? Or
Yeah, Project Honeypot, worked with those guys a couple of years ago. The project really never took off. It was good ideas, but ultimately it's your responsibility to pull IP addresses in a central database that, hey, these are known hackers. They're not really known hackers. It's a botnet. It's a compromised Windows PC, something of that nature. It's not somebody specifically doing it. These are automated mechanisms that go out and they infiltrate people's computers. And you just get to a point where, do I want to spend this much time and effort trying to build the community and build this honeypot PBX and collect all these logs? For what purpose? You got to ship those logs out to valid people that want them and that are going to do something with them. But typically it's incumbent upon you to take care of your own. The project just never took off. There was good effort though. It was great effort, really smart people that wanted to do it, but it just didn't take off.
There's actually a similar project, but unfortunately Windows-based, called PureBlock. I don't know if anyone's worked with it. I actually have Windows PBXs that I ended up using that to secure my networks from remote attacks, because at the firewall level I couldn't push the policies fast enough to prevent the PBX from being compromised. Pardon me. So with the peer-to-block lists, they just come in text-limited files. So if anyone is looking for a list of, hey, here's China's IP, here's Eastern Europe, here's wherever, those lists are maintained by PeerBlock members, and you can submit back to that, and you can also pull from it, and they're just CSV files.
Yeah, so there's a good project to look into. Any other questions? How are we doing on time? We're a little over.
Probably a little over, but
it's lunch session.
This is a great topic. This will be the last question, I guess.
So You had a slide with tons of different IP addresses. Like, I assume that's what happens when you get hit with a botnet. where
Yep.
They're just gonna, you block an IP, they're gonna go to the next one.
Sure.
Instead of blocking, is there a way to just maybe still respond, but
Send them the ping of death.
no, just
Blow up their
just wait a
terminal?
second. Just wait a second, like a tar pit where you don't block them because then they know they're done. Just slow them down, throttle it.
I guess you could, but I don't see why you would want to do that. If you're trying to compromise my network, I'm not just going to entertain it. I'm going to stop it and go do something else. It's really trivial. These attacks come from all over the place. They're constant attacks. It's not something that I'm really, spend a lot of time and a lot of cycles worrying about and poring over and trying to mitigate this. I mean, I've been running this system now for years and years and years, and it just sits there and works, and I sleep at night. So it's not I go do other things than worry about hackers.
Okay, I think it's about time for an excellent box lunch. Thank you, J.R. J.R. Richardson, great presentation.